Are there any other notes on this?
Hi, Stan with 3D PT. For this video, I'll show you how I made a gigantic Makey Makey control board using materials such as fluted plastic, 3D printed electronic arrows, and other common materials. This is a great project for STEM teachers. It helps as a big demonstrator. You could also use it for different activities, or you could even do other things such as accommodate special needs by making a large controller with this, or having different activities for your students with this board. To 3D print this, I used Tinkercad to design a large arrow press key, and the file will be included in my teacher pay teacher link. But to print an electronic version of this, you need a special filament from ProtoPasta, known as conductive PLA. And this one is basically PLA with a lot of graphite mixed into it. And you could actually write with this material. It's the same as a very hard black pencil. When you print with this, make sure you always purge your hot end after you're done, because the material likes to leave behind a lot of residue in your hot end. If you don't have access to conductive PLA or don't want to buy a whole spool of it, you can instead print with normal PLA. And I did a sample here, and you would just have to cover these with aluminum foil after you're done. After you print your arrows, you could go to a print shop to have the Makey Makey board printed professionally like this. And for this one, I actually printed it with a whiteboard coating. That way I could write on it. And if I take this and have the students play on it, they're less likely to make a mess. But it was pretty expensive if you have it done professionally, like a FedEx Center or Kinko's or anything like that. Another option is you could actually project this onto a big board and just have your students manually draw it on. If your district has a printer, that's great. But for me, I ended up having to print it on its own poster paper and then mount it later to the backing board. And the backing board is actually fluted plastic that you see used a lot for lawn signs or political signs. So you could actually recycle those signs pretty easily. Or you could go to any sign shop and just ask for sheets of fluted plastic. This is really durable and waterproof. And it's actually really easy to work with. I've loved using fluted plastic over foam core because the foam core tends to be a bit fluffy. To prepare the boards, I actually had to use two fluted plastic boards, and so I had to had a student cut the boards down the edge to give it a nice clean edge, and was then used packing tape to join the two of them together. After this, after joining the fluted plastic boards together, I then put glue stick on the boards and press the poster down. Put plenty of weights on top. Also had clamps and some wood cauls and some other things. So I put all that on top to really press all of it down. And you'll probably also want to use some packing tape on the edges to really secure those. So while that glue is drying, you could have the students do the other pieces or mark where the holes are going to be drilled for the next parts. Using the arrow pieces, you could use them to mark where the holes are going to be drilled. And you could also mark the rest of the points on the board where holes need to be drilled. And this just helps you find where you need to drill for everything. To do the space and click key on this large board, I just use a scrap cardboard, just like the original instructions had. And I use a large roll of tape to mark as a way to mark the circle. So after this is done, you'll cut the circles out, glue one side of the cardboard to aluminum foil, flip it over, put glue on the other side, and secure down the aluminum foil on the back side of that. And that way you'll get a big shiny button. Now I did it with cardboard on this, but I'll include a 3D printed version in the teacher pay teacher file. Next we want to make the earth bar, and this is basically just done the same way as the space and click key. The only difference is we have a long piece of material, in this case it's some scrap fluted plastic, that will be cut to the length of the earth bar on the poster, and then glued and covered with aluminum foil just like before. This will also have more holes in it. It's kind of up to you whether you want to just put in a couple nuts and bolts, or if you want to put them on every single contact point, just like the original Makey Makey controller. I did it just because it kind of models what a real Makey Makey PCB board looks like. Here we're drilling holes through the poster and the fluted plastic. Make sure there's a scrap board underneath so you don't drill into your table. And the reason I do this is because it'll be easier to insert the bolts and thread them through this way. Now you could also use a soldering iron to do this, but that's going to be a bit smoky and a bit messy. You could also, and so I used the drill, and I think I had about a 1 1/4 inch bit on it. Just check it against the nuts and bolts that you'll use in your project.
And it's okay if we go through.
So bolt and washer on the back, and the wires will connect to that. And then a washer, nut to hold the panels together. After you have all the nuts and bolts threaded through and secured, just hand tighten them. Don't wrench them down with a wrench, because you might have to come back to this. You'll have to come back to rewire this and do field maintenance. So it's better if everything's just hand tightened. Next thing I'll do is you'll want to mark the wiring path for each of the buttons. So you just need to pick one that'll go up to where the Makey Makey PCB board is. And I just use different Sharpie colors to mark each path to help me out. Notice that you only need one wire going from the earth bar up. If you try and put more on, you might actually cause a short. So in general, you only need one wire going to one point of each key. So next is probably one of the harder steps, where you actually wire the board. So here an instructor I work with named Ollie is actually has more experience with this, so I let him lead on that. So you measure the length of wire you need to go from the bolt to the board to the PCB, add a couple inches on each end, and then use wire strippers to remove the insulation. In this case, we're using what's called SIP wire, which is pretty easy to work with. I think it's about 18 gauge wire. You could also use old phone cord. And take your time connecting the wiring to the board PCB and to the bolts. And this just takes I think it took us about 15 minutes to get everything wired up. And when you get to that point, wrap the wires around the bolt and then tighten them down on the back. And you don't want to like ratchet down again because you might want to field maintain or check it in the future. Also, this would be a great activity like if you have students that want to practice their wiring skills, have one of them wire it up and the other deconstruct it. Or you could also add on things. I actually want to add on LEDs to this at some point so it actually reacts like a full regular PCB instead of just being a simulation at this size. But you could definitely play around and add other things onto this as a future activity. A couple days after I built this, I looked on the back and I actually found that on the PCB, the pins on the left-hand side of the original Makey Makey controller had actually been knocked off, and I did realize that they stuck out a bit. So I quickly made this frame to go around it, and I'll include the files for this as well. But go ahead after you wire in everything, put this frame around it, and make sure it protects everything around the board from the wires to the pins, because this board still works, but I won't be able to wire it up with pins that should be on the left. Just like the regular Makey Makeys, you plug in the board to the USB cable into your computer. You always have to be touching the ground or the earth bar, and then you can wire up your connections using the alligator clips. And for this, I used carrots and celery. I did that so I could avoid any food issues, because I haven't heard of anyone being allergic to carrots or celery, but also they're pretty sturdy. So if you have students that tend to be heavy-handed with things, it's a whole lot harder to smash up celery and carrots by hand than it is like something like bananas or any other kind of fruit. These also tend to keep a lot longer, so you could put them cut them one day a week and have them throughout the week in some cold water.
Okay. Are there any other notes on this? Wait.
Wait, 3D PT.
Now, if you have them all touching each other,
That's not going to work.
you don't want them touching each other.
That's what I'm trying to do.
No.
Yep.
One there, one there, one there.
And
Okay.
Thank you for watching. If you like what you see, please like, comment, and subscribe. I'm adding new content for 3D printing and STEM all the time. The link to the files for this can be found in the description below for the Teacher Pay Teacher download. And in the future, I actually have another project planned where I'll be making a arrow key with 3D printed press and dies. So stay tuned for that.